closed rigid vessels A, B, and C without energy transfer with the surroundings, which initially contain three different gases at different temperatures, are connected by tube of negligible volume. The vessel A contains 2 moles of neon gas at 300 Kelvin. Vessel B contains 2 moles SO2 at 400 Kelvin. And vessel C contains 3 moles CO2 gas at temperature 500 Kelvin. What is the final pressure in ATM attained by the gases when all valves of connecting three vessels are opened and the additional 15.6 kilocalories heat is supplied to the vessels through the valve? The volume of A, B, and C is 2, 2, and 3 liters respectively. The value of R has been given as 2 calories per mole Kelvin. CV of neon is given as 3R by 2. CV of carbon monoxide is given as 5R by 2. And CV of SO2 is given as 3R. Now we know that for all of these gases, since energy transfer is happening only between them and there is an additional amount of energy provided to them, we can say that the total heat received will be equal to the heat supplied, right? So the total heat received, let's consider the final temperature to be T, okay? So the total heat received will be, for neon, it will be the number of moles of neon, that is 2, into CV of neon, that is 3R by 2, into delta T, that is T final, minus T initial for neon was 300. Similarly, for SO2, we have number of moles of SO2 is 2, into CV for SO2 is 3R, into delta T is T final minus 400 Kelvin, plus for CO2, we have 3 moles of CO2 into R is 5R by 2, into delta T is T minus 500. And this entire quantity is equal to the heat supplied. And the heat supplied is 15.6 kilocalories, which can be written as 15600, right? And the value of R is 2 calories per mole Kelvin. Let's just plug in the values and try to separate out the terms. So 2 into 3 by 2 into 2 times T minus 300 plus 2 into 3 into 2 times T minus 400 plus 3 into 5 into 2 divided by 2 times T minus 500. These 2's get cancelled out. This 2 also gets cancelled out. Let's combine the terms now. So from the first one we get a 6T. From the second one we get a 12T. And from the third one we get a 15T. So 12 plus 15 will be 27, plus 6 will be 33T, right? Minus 6 into 3 is 18, and 12 into 4 is 48, right? There'll be a minus sign here. And 15 into 5 is 7500. So 1800 plus 4800 plus 7500 will give a 14100 right here, and this is equal to 15600. So 33T will be equal to 14100 plus 15600, that is 29700. and this divided by 33 will give us the final temperature, which comes out to be 900 Kelvin, right? Now we have the temperature. We have to calculate the pressure using PV is equal to nRT, right? So pressure into what is the total volume? The volume of individual containers is given as 2, 2 and 3. So the total volume will be 7 is equal to the number of moles. The number of moles will be 2 for neon plus 2 for SO2 and 3 for CO2. So this is also 7 into R and into the temperature, that is 900 Kelvin, right? So when we've plugged in all these values, the 7 gets cancelled out, and since we need pressure in ATM, we will plug R accordingly. So it will be 900 multiplied by 0.0821, and this value comes out to be 73.89 ATM. And so your answer will be option A.